Hello, my name is Joshua White, and I'd like to demonstrate for you my final project, a 4-bit microprocessor. So here's my clock, comes from the Logism library, so that I can just press 2 keys on my keyboard, and it will activate and deactivate according to a certain frequency. Frequency is 32Hz, quick enough to cycle through everything and then loop back over. The binary counter will take its value and put it into prom, and prom will move one by one down this line and activate these lines accordingly. First 4 go into my MUX, second 4 go into the instruction coder. Decoder, according to what input it gets, will activate one of these lines here. And these outputs will move onward to these 4 subcircuits. The MUX takes the value from the prom and also from the ALU block, and according to this input from the decoder, will choose which of these inputs to output. And then that information goes to the register, and according to these lines here, with a demultiplexer to allow me to do both A and B. They move throughout the register and then store that information to either this one or this one, depending on which address is activated. That information then goes down the line to either the display or the ALU. The ALU, according to the select lines, will decide which of these MUXs will accept these 4 functions, these 4 registers. Here's the 4-bit adder with this input right here deciding whether or not it's an adder or a subtractor. And then here's the AND, the OR, and then the XOR. Here is my 4-bit register, which is used for a few different subcircuits. And then here's the adder bit with all the needed logic to decide adder or subtractor. Then the ALU will take that information and with the accumulator, also a 4-bit register, sends that information back to this MUX right here. And according to, as I said, the control line on the MUX will decide whether or not it will take that information from the ALU or from the prom. The register will then move this information according to this code right here. The and OR are not in the same lineup because AND is 1 lower than OR with the selector lines. Here's the read register subcircuit, the file decoder from the ALU, and the data MUX, as you can see. Now, I will now demonstrate for you the program. This first 4 minus 3 equals 1 is actually uses a 2's complement. Took me a while to get the coding for that figured out, but eventually it worked. I actually had to utilize XOR and OR in order to do so. And this one right here uses subtractor. As you can see, it cycled through another time. Okay, I will turn it off, clock off, and then clear, so that it's back to square 1 or the origin. Hopefully you enjoyed that demonstration. Have a good day.